Alright, hey Stat 113 crew. So we're gonna kind of finish up this week by talking about this t distribution. And so just to kind of remind ourselves what we did for confidence interval for proportions is that we had this kind of sample proportion plus or minus this z star times a standard error, where that z star came from the normal distribution. And so as we're thinking about moving forward into building a confidence interval for the mean, we're just going to kind of note that, well, just right before this, we said that the standard error, or the sampling distribution of the mean, was this sigma divided by square root of n, where the sigma was the population standard deviation. The problem with that is that if we don't know the population mean, we probably don't know the population standard deviation either. And so we won't really be able to use this as our standard error because we don't know what sigma is. To remedy that problem, we will end up using S, which we said before was the sample standard deviation. And so instead of using a standard error of sigma divided by square root of n, we're going to end up using S divided by the square root of n. In order to make that substitution that doesn't really come for free, we're going to end up using a different distribution to get these critical values. And that distribution is this t distribution. So you can notice from this picture that it has fatter tails than the normal distribution, but otherwise it looks pretty similar. It's still bell-shaped-ish, and we're going to still end up using StatKey to find like our t star values or to get a p-value from the hypothesis test. But instead of using the normal distribution, we're just going to use the t distribution from now on. And so how fat the tails are just controlled by something called these degrees of freedom. When we're in the simplest possible setting, the degrees of freedom are always going to be equal to n minus 1, which is our sample size minus 1. In the end, I don't think it's like wildly important that we understand exactly why we're using this t distribution instead of the normal distribution. I think this is one of a couple of instances where we're just noting that this is an applied stats class, not a theoretical stats class. And so we're just kind of taking this use of the t distribution as is. There's a note on here at the very end that if you ever did know the population standard deviation, then you could just use this z star instead of something from the t distribution. We'll get into more of like how to find this t star from StatKey in the next section when we talk about confidence intervals. But other than that, this kind of wraps up the stuff for this week. So as always, let me know if you have any questions. And have a great morning, afternoon, or evening.